Hello, Honors Algebra 2. Today, we're going to look at notes for 8-1, which is a starred section, multiplying and dividing rational expressions. Our objective is to multiply and divide rational expressions. Big surprise there, right? This is going to require our 5-1 skills, our operations on polynomial skills, and you're going to see that a lot of this is going to be extremely similar to the operations. It's an extension of the operations on polynomial stuff. So I'm going to start a new board here, and we're going to start our first example. So example 1, we want to simplify the following. This is example 1, part A. We're going to simplify the following expression. Remember, these are expressions, not equations. 5x times the quantity x squared plus 4x plus 3. All of that over x minus 6 times x squared minus 9. So a couple of things to notice about this, and the general strategy for this strategy here is going to be that you want to factor and cancel absolutely everything that we can factor and cancel. And then we might want to make a note of where it's still undefined. Okay? So, notice that up here I have this trinomial, this quadratic here, and if I look at this, because there's nothing in front of the x squared, then I want to say, what two numbers can I multiply to make that number, and do this to make that number. Okay, so what two numbers am I going to multiply to make 3 and add to make 4? So as this comes down here, I'll leave the 5x here, and two numbers that multiply to make 3 and add to make 4 are 3 and 1, right? So if both of these are addition, then you get an x plus and an x plus, and two numbers that multiply to make 3 and add to make 4 are 3 and 1, and it doesn't matter what order I put them in because I've had x plus in both. Okay? Over, now this one does not factor, so I'll leave it as x minus 6. But this one here, that one there is a difference of squares, and a difference of squares. And a difference of squares always looks like two things squared and subtracted, and it always factors into the square roots added times the square roots subtracted in that same order. Okay? So I've got an x squared here, I've got the minus, and I've got the 9. And so if I just take the square roots of everything, that'll be x. Square root of x squared is x, and square root of 9 is 3. So if I put an x and a 3 in each, and a plus for one of them, and a minus for the other, there I have factored that difference of squares. Now you cancel what you can. Notice that I have an x plus 3 here, and x plus 3 here, so I can cross those off and write what's left, which is 5x times the quantity x plus 1 over the quantity x minus 6 times quantity x minus 3. And then you might want to think about the fact that you don't want zeros in the denominators, so x cannot equal 3 or 6, because if it was 3, you'd have 3 minus 3 is 0, and you'd have 0 times something is still 0, and you'd have 0 in the denominator. If it was 6, you'd have 0 right there and have the same thing happen. Okay? So let's move on to example 1, part B then. Example 1. We're still going to simplify. This is now part B. And the question for part B was, when is the expression in part A undefined? And we said that was when x equaled 3 and when x equaled 6. And for the graph, if we were to be graphing y equals that expression, that would mean that there would be vertical asymptotes at x equals 3 and x equals 6. So if you were thinking about graphing it, that's where that would come from. Okay? So I'm going to move on, and we're going to skip example 2 in the book, and we're going to go right on to example 3, which is another simplify problem. So we want to simplify the following problem. 4w squared minus 3wy, all that in parentheses, times the quantity w plus y, all of that over 3y minus 4w times 5w plus y. So the question here is, how do we manipulate things so that there's at least one thing that we can cancel? And what you need to notice is there's a 5 here, but there's no 5 with the y, so I couldn't factor a 5 out of there. So these two are never going to be the same. They look like they're real close, but they're never going to be the same. On the other hand, those two, notice that there's a w squared there and a w there, and so I could factor a w out to the front of that and have 4w minus 3y times w plus y, all of that over 3y minus 4w times 5w plus y. Now, that looks real close. These two look real close, and let me show you just how close they are. They're off by a negative. If I change these minuses, if I change this minus here to a plus negative, and change that minus as well to a plus negative, they're off by a negative. The things that are negative at the top are positive at the bottom, and vice versa. The way we fix that is, all I have to do is, and I'll do it over here, all I have to do is factor a negative out of this. Okay, so if I factor a negative out, then the 4w becomes a negative 4w, and the negative 3y becomes a positive 3y. And then I still have this w plus y up here. And on the bottom, I have positive 3y plus negative 4w times 5w plus y. So all I have to do now is do this w times that negative, and I'll have something that allows me to do what I need to do. So then I can have negative w times, and let me put the positive 3y first, plus the negative 4y second, times w plus y, all of that over 3y plus negative 4w, whoops, sorry, I messed that up here. It needs to be negative 4w times 5w plus y. And then, of course, these two would cancel, and you'd have negative w times w plus y over 5w plus y, the parentheses no longer being necessary there in the bottom. And you want to be very careful. This is the final answer, and you could not simplify that. You couldn't do something like cancel w's on top and bottom, because you'd have to have w in both of those so you could factor it to the front, because you can only cancel between multiplication. You cannot cancel between addition. All right? So something I want to remind you of now as I go to a new board here, a definition that I want to remind you of is that division is defined as multiplication by reciprocal. And we've dealt with this before, and just to remind you, this means that if I've got some stuff, some a divided by b, that's the same as a times the reciprocal, 1 over b, or if I have an a over b divided by an x over y, that's the same as a over b times the reciprocal of x over y, which is y over x. Or if you have an a over x over y, that's the same as a times y over x. And remember, the multiplication only happens at the top in that case. Okay, so that is division being turned into multiplication by reciprocal, and that's going to show up in our next example here. This is example 4 out of the book for this section. And again, we're going to simplify here. And this has two parts to it. So part A is going to be 6c over 5d times 15cd squared over 8a. Okay? So this is still multiplication, so I don't have to use that definition of division because I'm not dealing with division. What I can do is multiply top times top, bottom times bottom, and see where things lead me in. In the cases where you're looking to cancel stuff, and that's again what we're looking to do here, in the cases where you're looking to cancel, it actually winds up being helpful if you factor even the numbers into smaller pieces. For example, 6, I can call 2 times 3. 15, I can call 3 times 5. And then c times c is c to the second, and this d to the second stays there. The 5 is a prime number, so I'll just leave it as 5. 8, I could write as 2 times 2 times 2, or 2 times 4. The reason I'd write it as 2 times 4 is because the 2's will cancel them, times a times d. Okay? And then, so the 2's will cancel, the 5's will cancel. And remember, you can only cancel between multiplication. So the reason I'm able to cancel here is because there's no addition or subtraction in this. And then this d squared means I have 2 d's here, d times d. So I can cancel one of them with this d down here. And so I wind up getting, let's see, I got 3 times 3, so that's 9, c squared, and a single d, d to the first or just d, over, I'm left with a 4 as a number and as a variable a, so over 4a. So there's my simplified answer. So that was example 4, part A. Let's go to example 4, part B. Example 4, we're still going to simplify. Now we're doing part B. And in part B, we're going to use the definition of division. So we're going to have 18x y to the third over 7a squared b squared divided by 12x squared y over 35a squared b. Now, I'm using this symbol because it's in your book, but I don't really like using that symbol. I'd rather write it as a fraction, as a big fraction. So let me do that over here. We'll write it as 18xy cubed over 7a squared b squared. All of that over 12x squared y over 35a squared b. And then we're going to take this division problem and turn it into multiplication by reciprocal. So that's going to be 18xy cubed over 7a squared b squared times. So one of the mnemonics for changing division into multiplication by reciprocal is keep. You keep the first thing, change to multiplication, keep, change, flip. So then you flip the second part, so that would then be 35a squared b over 12x squared y. And then we simplify as we did in the last one, and I'm going to write things out now. 18 could be written as 9 times 2, could be written as 3 times 6, but could be written as 2 times 3 times 3, and that's how I'm going to write it so I can really look at everything. So I just broke down 18 there. 35 is 5 times 7, and then I've got, let me write the letters in alphabetical order here, an a squared, a b, an x, and a y to the third, over, and then I've got 7, and then 12 is 4 times 3, or 2 times 2 times 3. I'm doing this so that you can see exactly how the cancellations are going to work. Okay? And then times a squared times b squared times x squared times y. And then cancel everything that you can. One of those 2's at the bottom cancels the 2 at the top. One of the 3's at the top cancels the 3 at the bottom. The 7's cancel. The a squareds completely cancel. The b at the top can cancel with one of the b's at the bottom. The x at the top can cancel one of the x's at the bottom. The y at the bottom can cancel one of the 3 y's at the top. So once we've got all that crossed off, I've still got 3 times 5, so that's 15. I've canceled all the variables except 2 of the y's. So it's going to be 15y squared at the top. In the bottom, I've only got the 2 left. And then I've canceled all the a's. I've only canceled one of the 2 b's. And I've only canceled one of the 2 x's. And so I get that answer right there, 15y squared over 2bx. Okay? So that is example 4. We're going to move on to example 5 now, and it's just more simplification. Example 5, simplify. And it has 2 parts to it also. So we'll do part A, and these are just getting a little more involved as we go, that's all. X squared minus 6x minus 16, all of that over x squared minus 16x plus 64 times x minus 8, all of that, over x squared plus 5x plus 6. Again, I want to point out that this is multiplication here, so no need to multiply by the reciprocal because we're already multiplying. You only do that with division. Now, I've got a whole bunch of quadratics here, a whole bunch of things that at least potentially could be factored. So I'm going to work on the possibility of factoring them. So let's see here. I've got 2 things that need to multiply to make 16 and need to subtract to make 6. Everything just has an x squared, so that's nice. I can do x and x. If there's a minus right there, one of them is always x plus and one of them is always x minus. So then you need to think about what 2 things can you multiply to make 16 and subtract to make 6. So let's see, you got 4 times 4 is 16, but 4 minus 4 is 0, so that doesn't work. But 2 times 8 is 16, and 8 minus 2 is 6. So it's 2 and 8, and then the bigger one always goes with that sign, so it's 8 and 2. And then in the bottom, I'm going to do the same thing, 2 things that multiply to make 64, and add to make 16, and I have x and x, and when I have a plus right there, both of them are that. So it's x minus and x minus. And then 2 things that multiply to make 64 and add to make 16 are 8 and 8. because 8 times 8 is 64, and 8 plus 8 is 16, so this is 8 and 8. You may have also recognized that this one that we just broke down is a completed square, is a perfect square, and if you recognize that, great. However, I would recommend still writing it as x minus 8 times x minus 8 instead of x minus 8 quantity squared, because you're going to want to do all the canceling. And as you can see, there's two x minus 8s in the top that are going to wind up canceling. So let's factor this one down here before we get to that. Two things that multiply to make 6 and add to make 5. Plus here means they're both this, so it's x plus and x plus, and two things that multiply to make 6 and add to make 5 are 2 and 3. They're both pluses, so there's no worry about order. And then you cancel things on the bottom with things on the top. But remember, you can only cancel between multiplication. So this x minus 8 can cancel this x minus 8. This x minus 8 can cancel that x minus 8. This x plus 2 can cancel that x plus 2. And with nothing left in the top, you put a 1. And in the bottom, I have an x plus 3. And then I probably want to note that x cannot equal negative 3. That tells me where the asymptote is, things of that nature. All right, let's do part B then. And this is example 5. We're still simplifying. This is now part B. And in part B, we've got x squared minus 16 over 12y plus 36 divided by x squared minus 12x plus 32 over y squared minus 3y minus 18. So again, I want to do all the factoring, and once I do the factoring, I'll do the keep, change, flip, and all that. But let's save that to the end, okay? So here, again, I have a difference of squares, which means it's the square root and the square root twice, once added, once subtracted. In the bottom here, you might notice that there's a 12. Both of these numbers are divisible by 12. So let me factor that 12 to the front. And I would get 12 times quantity y plus 3, because that might help me a little bit later. You know what? Instead of writing the division sign, I'm going to make this a real big fraction. So let's see here. Here's something to factor. A plus here means that it's both that, so it's x minus times x minus. And then I need two things that multiply to make 32 and add to make 12. And if you think about that, that's 4 and 8 over. And then I want to factor this one in the same way. A minus here means one's going to be y plus, one's going to be y minus. And then two things that multiply to make 18 and subtract to make 3 are, well, 6 times 3 is 18, 6 minus 3 is 3, so it's 6 and 3 with the bigger one going with that sign, so 6 and 3. So then we got to turn this into multiplication by reciprocal. I'm going to have to write a little bit smaller to make that happen. X plus 4 times x minus 4 over 12 times y plus 3 times, bottom becomes top, top becomes bottom. Keep, change, flip. So that's y plus 3 times y minus 6 at the top, and at the bottom x minus 4 times x minus 8. And then you can start canceling stuff. The x minus 4's cancel, the y plus 3's cancel, and then write down what you're left with. X plus 4 times y minus 6 is what's left at the top, and 12 times x minus 8 is what's left at the bottom. Now, if you're asking me, why didn't you multiply that all back together? Why didn't you do the distribution? Well, because it's not necessarily something that you need to do. It's just something that might work later, but a lot of times in these problems you're looking to cancel stuff, so you want to keep it really as far apart as you can. One more example with 2 more parts. Okay, example 6. Again, we're going to simplify. And again, it's got 2 parts. We're going to have a minus b, all of that over 4 divided by a squared minus b squared all over 4. So this is just another division problem. We're just going to turn it into multiplication by reciprocal. We're going to factor things, all that good stuff. So let me turn it into multiplication first, just because. Keep, change, flip. And then the only thing to factor is that thing right there. It's a difference of squares, so I've got a minus b over 4 times 4 over this difference of squares, which is the square roots. The square roots, once added, once subtracted. So the 4's cancel, the a minus b's cancel. If you have nothing left on one of the sides, it becomes a 1, especially at the top. If it becomes a 1 at the bottom, you can ignore the bottom. Over, and the only thing left on the bottom is a plus b, and so there you have that one. One more. So this is example 6, still simplifying. And this is part B now. And we're going to do x squared over x squared minus y squared. All of that over 4x over y minus x. So this is just one with some tricky stuff here. It's just tricks. It's not really anything new. But let's keep doing the same thing. Write it as keep, change, flip, multiplication by reciprocal. Change the division into multiplication by reciprocal. So the first thing times, the second thing flipped over. And then I can factor that. So let me do that. X squared over that difference of squares is x plus y times x minus y times y minus x over 4x. Now, how are we going to deal with all this? Well, I can cancel this x with one of those x's, so that's pretty easy. So I have x there now instead of x squared, times, now over here I have plus a negative x. Minus and plus negative are the same thing. And down here I have plus a negative y. So what I'm going to do is I'm going to pull the same trick I did a couple examples ago, and I'm going to factor a negative out of that so that the first one becomes a negative y and the second one becomes a positive x. And what that's going to do for me is I've got this x plus y and then this x plus negative y and then this 4. But now you should see that this one and this one are now the same. Okay? So now I can cancel these two, and I can multiply the x times the negative, giving me negative x at the top, and then 4 times the quantity x plus y at the bottom, which I may or may not distribute, depending on what's easier for me. Okay? That is it. That is the last example. You will find your assignment in PowerSchool. Thank you.